Great. I guess this is a lot better now. Sorry about that.
Yes.
We are a manufacturer based in Chennai, in Ambattur, and we make company is Onload Gears, which is an established manufacturer of onload tap changers, which is high voltage equipment used on the secondary side of distribution transformers. We just to quickly introduce the founders. It's Mr. S.V. Gopalan, who is the founder and CEO of Onload Gear. 50% of the all designs really are in-house with core manufacturing capabilities, and that's the culture we bring to CANFAN as well. All designs are in-house. We develop them completely in-house, and that we consider as our core capability. My name is Ram, and I'm the second founder. As ICICI and experience, and then by training and a variety of management and technical degrees. Quickly dive in. We make two types of fans now, and still this is a little bit of work in progress. We see several product extensions, but I will not take your time talking about those at this point. But let me talk about the two that we have right now. So the first is what we call a man-cooler industrial locations. And this is meant to actually provide comfort to workers, typically induction motor fans at this point. And what we provide is the alternative, which is using BLDC technology. Right? And let's talk about them first. So you have, it looks pretty much like, the traditional green colored almonad fan that I'm sure lots of you must have seen. And you've got
Ram,
pretty much like that, but yeah.
Sorry, I'm sorry to interrupt.
Hear me?
Yeah, so there are interruptions. So our request is if you can just try switching off your video, because that will help with the bandwidth, one. And second, the presentation is not in the slideshow mode. If you can just put it in the slideshow mode as well. I think that will be really helpful.
Better?
Yes, the video, the presentation is good. I think if you can, audio seems to be fine. So I think you can proceed now. Thank you.
Yeah. Okay. Thank you. Yeah. So the idea in a BLDC fan is to take basically one between the rotor and the stator, which is the fundamentals of a motor, take one of them and replace them with magnets instead of windings, and that provides basically the savings in energy, and that's what gets reflected as energy savings in a brushless DC motor fan. But then what has to happen is the electronics has to provide what's traditionally done with traditional commutation is replaced with electronic commutation, and that's what this electronic box is all about. And I won't dive into what the technology is per se, but we'll talk more about the applications at this point. So you look at this brushless DC motor air circulator, right? It's used again typically in factories, where 2 to 4% of the total energy of a factory comes from these traditional air circulators. You look at Renault, Nissan, Hyundai. You can name your pick. I guess it's going to be higher probably in steel companies and so on and so forth. Now it runs usually 16 to 20 hours per day, and typically unions require one fan per worker. Right? That's the scenario. Shop floor managers typically see these traditional fans as high maintenance, and they're replacing them every 3 or 4 years with coil burning, issues, and then they have to actually rewind them, and they do it one more time and then throw them away. So these fans typically last just 5 years or so, which is from a waste management perspective, it's crazy. Not just does it consume a lot more energy, but it's also leads to a lot of waste. Now, the brushless DC motor air circulator is a very cost-effective alternative for replacement of traditional fans, not just for new buys, but for replacement. And that's the market that we're looking at quite actively, of course, in addition to new buys. It consumes 38% less power, of course, 45% low VA consumption, because the power factor of these fans is 0.95. Far higher air delivery, and of course it has a 3-year warranty as compared to a 1-year warranty on traditional air circulator fans, right? And again, payback is between 2 and 2.5 years. Of course, if you go to Maharashtra, this payback is 1.25 years or so, because the rate of power costs are very high. And going forward, this payback is only going to get better with the cost of power actually increasing over time. So the energy savings times the power rate gives you actually savings in rupees, and that's kind of going to increase because the rate of power tariff is going to continue to go up. We also have a lease model as a part of the value prop, where the cash, really what happens is the cash surplus, cash, energy savings translates to rupee savings, and then you pay for the lease, and then you're left with some at the very end. So this is particularly helpful in cases where capex is a constraint, COVID times, etc. We find this to be the case, and this is typically available to marquee customers, large companies, etc., which are creditworthy. Let me jump in. Here are some characteristics that you can see. We're contrasting. In orange is the traditional fan, and in dark blue is the air zone fan at the top speed, and the lighter blue is the air zone fan at the 1 speed lower. So the key operating metrics: air delivery, power consumption, and service. Delivers 400 meter cube per minute in air delivery. Ours delivers 650 cubic meter or so of air delivery. Power consumption. We consume 160 watts at this point. Whenever it seems some consume 250, the performance degrades over time. In the case of a brushless DC motor fan, it remains steady forever because it runs very cold. Right? And finally, as a metric of energy efficiency, how many meter cube per minute do you deliver per watt? At speed 2, we're at 4.03. That's 4. The traditional fan is at 1.5. So it's a factor of, give or take 3 times extent of savings we're talking about. Use case of, in an industry of 20 hours of usage, 300 days per year, and with electricity tariffs at 9 rupees per unit, this is Maharashtra. So you're talking about energy savings about 600 units per year. Cost savings of 5,400 rupees a year, which is pretty obvious. Savings per month is 450 rupees a month, and the payback period, given the cost of our fan, is less than 2 years, which is very attractive for industrial customers that we've encountered so far. Right, and this is based on today's tariff, and if this keeps going up, of course, the payback is a lot lower. And of course, if we take into you don't have to replace another fan at the roof, but not calculus at this point. Now, here's the lease case. So the monthly lease on your fan, here's an example based on a lease proposal that we've given to a client. You've got 250 rupees a month that pops up as a lease fee. This is illustrative, of course. Your monthly energy savings at in that particular case was 450 rupees. So you start off with 200 rupees cash surplus per fan, and remember, this is in the thousands, right? I mean, it can be in the thousands. It's 500 fans in some location. Continues through the period of the lease, let's say 3 years or 5 years. And after that, all the energy savings goes to their pocket. So this is, the lease model is phenomenally attractive for those that are trying to, not put CapEx out. Several of them say, hey, we have the cash and we will buy it up front and get all of the savings straight up and get a payback period of less than 2 years. So that's an option as well. So these two options that we have. Now, of course, here's the list of our clients. So we've got Ford, ITC, Mahindra, Godrej, Kobelco, Lucas, to name a few. We've got, several of them. And several of them we're starting off at Daimler, etc. So there's a wide, this is finding a lot of traction. So these fans come in a 750 mm, which is 30 inches dia, 24 inches dia, as well as 20 inches dia. So we've got the range on these fans. We also have man cooler fans, which operate at 250 watts, and they are in one of our customers right now. We're replacing a 750 watt, man cooler with our 250 watt man cooler by just position in which we actually deploy our fans, and so with a little bit of creativity on the shop floor. So that's just a little bit of an anecdote on one of our use cases. Now we come to ceiling fans. This is again based on the similar technology. Looks a bit different, like a traditional ceiling fan, right? We wanted to make sure that the aesthetic was simple looking and traditional looking. The idea is, this is a value product and we're looking at cost savings for the customer. So any perception of any jazz on this product basically implies in some ways that, there's cost we're incurring, which we might as well pass down to our end consumers, which is, we view our product as an energy saving product. And so that explains the imagery here. Of course, we can make this look fancy, and we probably will in a separate range. Another day. At this point, we've got these fans. It is definitely beginning to find a lot of traction. These have not caught on in the end user retail segment yet, because it is fundamentally it has a higher cost than the traditional fans, right? Now again, quickly on the operating metrics, clearly as good as, if not better than the traditional fan. Poor operating, they focus a bit too much on power saving while compromising air delivery. We never want to do that. So we're clearly ahead on air delivery than a traditional fan, and in many cases they tell us it's a bit too much. Can you run it at speed low? 82 as well in many situations. So say is 6.4 as compared to 2.8 in a traditional fan. Again, 2.3 service value shows the extent that this technology is able to deliver. And so it is not surprising that program, the ceiling fan was the one that was picked as the top candidate for deployment throughout the country. At some point, this is like the LED of fans, and the idea is that you've got 70 crore fans in this country, and if you look at saving 40 watts, I'll let you guys do the math. You're saving tens of billions of dollars and avoided capital cost of setting up power plants. And so this is a phenomenal energy footprint, right? Again, if you look at I won't go through the details here, but the idea that, you have a payback of less than 2 years, and daily saving of 7 rupees per fan. Particularly think of, don't think of your home of 3 fans, but think of, a college doing, replacement of all their, ceiling fans with our fans at this point. And so on the ceiling fan. Again, quick summary, very, very efficient, 55% energy savings. The BLDC fan, air circulator fan is about 40% energy savings. It runs very cold, no maintenance, no rewinding required at all. Longer warranty, we have a 5-year warranty on the ceiling fan as compared to traditional 2. 3 years on air circulator as compared to traditional 1, right? Again, ceiling fans are deployed in institutions, B2B, schools, shop floors, of economics, which drives traction, and folks are looking to buy. Less than 2 years on replace months, right? 3-4 months. But even if you were to take the old one and get scrap value for it, your payback period is less than 2 years. We also have the lease model and the ESCO model, that is some industries as well that have done this. So I will stop here. Thank you very much for your time.
Well, thank you, Ram. I think, just to sort of summarize, unfortunately, we were having a little interruption. So I would also like to summarize from Ram's point of view in terms of what they offer. One, what we understand is that there are 2 products. There is air circulators and ceiling fans, both BLDC, therefore super energy efficient. And Ram has clearly pointed out the differences.